multiplying and dividing. Just like adding and subtracting, we can use an algorithm to multiply and divide when we write out our working in our books, or we can use some mental strategies. So when we're multiplying in order to find the product of two numbers, for example, if we need to do 317 times 26, we know that the appropriate algorithm is to write the numbers on top of each other, and unlike adding or subtracting, we don't need to line up the values. Actually, we sort of justify them, we squish them up against the right-hand edge there, and we write a multiplication sign. We're basically going to do 6 lots of 317 and 20 lots of 317. And that will be 26 lots of 317. So 6 times 7 is 42. And remember, we put down our 2, and remember that we're going to have to tuck our 4 in. 6 times 1 is 6, plus that 4, which already had to be in here, is 10. Put down our 0, we're going to have to tuck a 1 in. So we've carried that to there. 6 times 3 is 18, plus 1 is 19. 9 goes there, and our 1 should end up over here. So that's 6 times 317. I then want to do 20 times 317. So it's going to be much easier to put down the 0 that we need for everything and then just do 2 times 317. So we put down our 0, and then 2 times 7 is 14. I'm going to carry a 1 over here again. 2 times 1 is 2, plus 1 is 3. And 2 times 3 is 6. Now that one there was 20 times 317. And I want 26 lots of 317. So 20 lots plus 6 lots. Add these together. 2 plus 0 is 2. 0 plus 4 is 4. 9 plus 3, we're going to carry again. That's 12. 6 plus 1 plus that other one. 6, 7, 8. And I've got my answer. At that point, if I had a calculator, I'd probably check to make sure it was all right. But that's the algorithm to find the product of two numbers. We can use the short division algorithm to get the quotient of two numbers, that is, what happens when we divide them. So, for example, for example, if we have 87 divided by 3, our short division algorithm says it's 87 divided by 3. And that's basically how many times does 3 go into 87? 3 goes into 8. 3 times 2 is 6. And the next one up is 9, so it goes in twice. The fact that it goes in twice, 2 up 3 is 6. 8 means I've got 2 left over. And 3 into 27. 3 times 9 is 27 exactly. So 3 goes into 87 29 times. If I wanted to check that, I could, of course, do 29 times 3. And I could probably do something really tricky there with a mental check. Obviously, if 3 goes into 87 29 times, then 29 times 3 should give me 87. It'd be very easy if it was 30 lots of 3. 30 times 3 would be 90. I only want 29 lots of 3, so I'd take away 1 lot of 3, minus 3. 90 take away 3 is 87. I was correct, and I used a mental strategy to check what 29 times 3 was. So we can use the algorithms, or we can use mental strategies. The one I just used here uses something called the distributive law, which says that I'm allowed to split up a multiplication. It's easier to demonstrate if I need to do 4 times 87. That 87 can be split up. I can have 4 lots of 80, and I can have 4 lots of 7. Or the other way to think about it is if this is 87 lots of 4, here's 80 lots of 4 and 7 lots of 4. That's 87 lots of 4. And the reason we might split it up is to make it easier. 4 times 8 is 32, so 4 times 80 is 320. 4 times 7 is 28. I've got 348, and I haven't had to do quite as much working. We can, as I did up here, subtract it instead. So I could have done with 4 times 87, I could have said, well, okay, 80 is pretty close to 87 and it's easy, but 90 is even closer. I could have had 90 lots of 4, take away 3 lots of 4. So I want 87 lots of 4, 90 lots, take away 3 lots is 87 lots. 4 times 90 was tricky, but 4 times 9 is 36. So 4 times 90 is 360. Take away 12. And same answer, of course, because we're doing the same sum, 348. So we've got mental strategies to help ourselves out. And I'm showing the writing here, of course, to show you what I'm doing. But the good thing with mental tricks is we don't need to